Hello, precious ones. Welcome to our class, and our session is still on our three-dimensional figures. Today we are going to look at prism. And when we talk about prism, prism is also a three-dimensional figure with a uniform cross-section. Uniform cross-section means that when we cut any length, when we cut it across the length, we may have what? The same shape as the original. Even let's look at the board. The board is a typical example of a three-dimensional figure. And we have the length, we have the breadth, and we have the height. Okay, the breadth is here, and then we have the height. It has depth. All right, it has thickness. Okay, so when I cut any portion of this particular board across its length, you realize that it will be the same as the board. No, we are going to look at triangular prism, we look at square prism, and we look at rectangular prism. Okay, we have already looked at cylinder, which is a circular prism. So that is what we are going to look at. So we are going to look at rectangular prism. Rectangular prism, which is also known as the cuboid. So a typical example can be this particular board. Think this board is in rectangular shape. It has the length, it has the breadth, and it has the height. All right. And then in school, normally the chalkboards that students use, it can also be an example of what? A rectangular prism. Okay, a box, chalk box is also an example of a rectangular prism or a keyboard. So let me draw my rectangular prism. We are going to look at the volume, and then we look at the total surface area. We look at the volume and then the total surface area. Okay. Okay, so this is how our cuboid is. So let's label the vertices A, let's say B, C, D, and say E, F, and then J, H. Okay, so this is how a keyboard looks like. And what you should know, the keyboard has 6 faces. 6. So 1 is here, down here 2, this side 3, this side 4, and then the further face here 5, and then this particular side 6. So before we can actually understand the total surface area of a keyboard, I think we should know the net. When we talk about the net, when we open up, okay, we open up this particular keyboard here, how it is going to be, okay, before we form it to be in this particular shape, like let's a box. All right, sure. So this is the net. Let's look at, since it has 6 faces, so let's look at how the net of a keyboard is going to be. And the net will definitely help us to calculate for our total surface area. So we look at the total surface area. Okay, so this is the net of a keyboard. All right, so when I look at the net of a keyboard, so let's say the base here, this particular face, let's call the A, B, C, and then the D. This is one face. Let's say the down here. All right, and then when I look at the left side here, okay, we have A, D, E, F. So A, D, and then let's say my E is here, and my F is here. All right, so my A, D, E, and F. That is this particular face. Okay, then let me come to this face. That is this particular side. Okay, this particular side have D, E, H, C. So DEHC, that is this particular side here. All right, then let me come to this side. JHBC. So BC is here. So I have my H here, and then my J will come here. Okay. So this one is going to, when you fold it and bring it as this one. Okay. The J and the H will be here. Then let's come down here. That is this particular face. Okay, that is this particular face. So A, B, F, and then G. So A, B, F, G. And then the last one, you look at the top here. That is this particular face here. So that is F, G, E, H. So my E, H will come here. So I have 1, 2, 3, 4, 5, and 6. So realize that the keyboard has how many faces? It has 6 faces. It has 6 faces. All right, that is our keyboard. Okay. So then we are going to look at the total surface area of the keyboard. But before that, you know that the keyboard is what? It's a rectangular prism. So this is our length. Let me use L. Our breadth. Okay, our B, and our height. Length, breadth times height, and then our H. Length and breadth times length, breadth, and then our height. Okay, so our length, our breadth, and our height. Okay, so that is how our keyboard is going to be. Okay, now we are going to look at the total surface area of the keyboard. So when we talk about the total surface area, we are talking about the area of all the 6 what? All the 6 faces. All right. So what we should take note is that this particular face here, okay, the ABFG, okay, this particular face is the same as the face here. All right. So the length here will be the same as the length here, okay? And then we have the height here to be the same as the height here. You get it? Sure. Okay. So the length here, okay, will be the same as the length here, and its height here will be the same as the height here. So this particular face becomes the same as this face. So what we should note that this face is the same as this face, and then the face here is also the same as the face here. Okay, and the face at the top is also the same as the face at the down. All right, so that is what we are going to. So we look at the faces that are the same, okay, and we multiply by 2. So 2 by the face of ABFG. AB what? Rectangle ABFG. Plus, so because the face of ABFG is the same as the face of DECH. Okay, they are the same. So because the length here, as we said, is the same as the length here. Okay, and the height here will also be the same as the height here. All right. So they will be the same thing. They will be the same thing. Plus 2 by, so let me take it off and then we continue from there. So let's also look at, we have looked at this face and this face. Let's look at the face at the left and the right. Okay, the left and the right. So the face here, the face BCHG, you should take note that it is the same face as what? ADEF. It is the same face here. All right, so here is my breadth and then my height. Look, here is also the breadth, and here also becomes what? The height. All right, so the face BCHG, okay, is also the same as ADEF. They are also the same. Then plus 2 times what? 2 times, okay. Then let's look at the top and the down. So the face ABCD, A, B, C, and then D. A, B, C, and D. And A, B, C is the same as F, E, H, J. F, E, H, J. So here is the same as the down here. So this will become my length and my breadth. And take note, here will become the length, and here also become the breadth. So we see that. Alright. So now we can write our total surface area of the cuboid. And take note, we are looking at a cuboid with a solid cuboid. Okay, all the sides or all the places are close. All right. Sometimes you can have a question that they can ask you. Let's say find the total surface area of an open cuboid. It means that you exclude the top. Or we can find typical example like let's say sometimes you can have a rectangular tank. Okay, that they put water in and then the top is not there, the top is open. Sometimes that would be a typical example what the masons they use at the construction site for building. They put water in rectangular tank and the top is open. You can also be asked a question on that particular one too. Alright. So now then that will be 2 by what is the face ABFG. Let's see, ABFG. So we have the length and we have the height. So the length times the height. Because we know that area of a rectangle is what? You multiply the 2 dimensions. Alright. So we have the length here and we have the height. And that is the same as this place. The length and the height. Okay. Then plus 2 times BC HF. BC HG, sorry. So that is the breadth and the height. Which is the breadth and the height. So the breadth times the height. Alright, plus 2 times area of ABC. That is the length and the breadth. So the length and the breadth. So the length times the breadth. So this is what we have. So what we are going to do now is to expand. Okay. So that when we expand, I believe that that will help us to actually come by our formula. So 2LH, all right, 2 times L times H plus 2BH, all right, plus 2LB. So this is what we have here. We have 2LH plus 2BH plus 2LB plus 2LB. So this is what we have. Let's see if we can factorize something out here. Okay, so we can have 2 here, 2 here, 2 here. So we can put 2 outside, and then we have LH, length times the height, plus breadth times the height, plus length times the breadth. So this becomes what? The total surface area of a cuboid, a solid cuboid, or we have all the places, actually the nodes, no side is open. All right, this is the formula for finding the total surface area of a cuboid. So when the question is maybe a top is open, it means that when you are finding, you don't include the top. All right, you don't include the top. Okay, so that is the total surface area of a cuboid. I know you have gotten it. So what we are done with the total surface area of the cuboid. We are going to look at the volume of the cuboid, the volume. So volume of a cuboid. Okay, so let's look at the volume. When we talk about volume is actually the amount of space in this particular figure, okay, or the space in the how much quantity it can contain. That is the volume. So most of the time when we buy water, okay, either bottled water or the sachet water, you see that the volume is written there. Okay, maybe 1 liter or 500 milliliters, whatever it is. All right, so that is the volume. That is the amount of space that particular container or the quantity that particular container can actually contain. All right, so that is the volume. And what will determine the size or the space within a container is actually the base and then the height. Take note, the base and the height. So you realize that if the base is wide, it is likely to contain more. But that is not enough to determine the volume. We have to look at the height too. So as the base is wide, let's say the height will also determine. As longer the height is, the more the volume. Okay, as shorter the height is, the less, or as the base. Okay, so the base, how the down is big, and then how long that particular container is will determine the volume, and that is the volume of the cuboid or any three-dimensional figure. So the volume will be what? The base area multiplied by the height. So what is the base area? The base area is what? Length times the breadth, and the height will be there. So length and breadth times height, that is the volume. So L, B, and then H. So this becomes the volume of a cuboid. The volume of a cuboid. And I know that when you are asked question on a cuboid, you'll be able to do. So that is the total surface area and the volume of a cuboid. So simple to understand. I know I will see you again in our next session on cuboid as we solve questions.